my name is Walter Unglob, and this is As Mass Increases, What Happens to Inertia? Well, it turns out that inertia would increase as well if the mass were to increase. One can see this in both the force equation and also the moment of inertia equation. If we consider force for a massive particle, the force is defined as the time derivative of momentum. And if the mass is changing, then we can use the chain rule from calculus to differentiate the momentum with respect to time. So we're going to end up with the change in the mass over time times the constant velocity plus a constant mass times the change in velocity over time. This, of course, is the acceleration. And we see that we can write down a differential equation, and as the mass increases, so too will the acceleration. The force will increase. So if the force increases, then it's going to be even more difficult to stop that mass from changing its trajectory. And this is viewed in Newton's first law of motion, where an object in motion or at rest will not change its velocity unless enacted upon by an external force. So the more mass or the greater the force, the more difficult it is to change its motion. And that's what inertia is. We can also directly look at the equation for the moment of inertia, which is equal to the sum of the number of masses times distance r squared. If we just have one mass, then the moment of inertia simplifies to just mr squared. And if this mass is changing, if it's increasing specifically, then the moment of inertia will also increase. So we see that as the mass increases, so too does the inertia. My name is Walter Unglob, and this is As Mass Increases, What Happens to Inertia?